Hello, welcome to the project demonstration video. Our project is a real-time fish measurement system which calculates the fish physical parameters. It measures the length and height of fishes. Our goal is to make a real-time fish physical parameters measurement system. In aquaculture, for trading fish in the market, it plays an important role to ensure the size, height, and length of fishes. But it is quite impossible to observe all the fishes in a fish tank. Normally, farmers choose randomly 5 to 10 fishes and measure their length and height manually and make assumptions for other fishes. This process is very time consuming and takes a lot of effort. As fish size is very important to know the growth of healthy fishes, some fishes can die for not being properly treated or wasted and make loss as it is not transferred in the market at its appropriate time. So our real-time fish physical parameters measurement system is an automated system. This system can easily eradicate all the problems that we faced in our aquaculture system. Our automated system provides the accurate data for estimating length and height. This system will be very convenient to use and it will be cost and time efficient. Now let's move to the hardware implementation section. This is our camera module. We have fixed it in such a way that it provides the exact location of object's position from our camera. These two cameras provide the exact distance from camera and the object. We have used two cameras to capturing a single object. These two cameras working on a dual mode to capture a 3D object. Cameras are working on a single focus. So it must need to be a same configurations to identify a single object. Now let's moving forward to our fish tank. It is the most important element of our project. As we are trying to implement a real-time fish physical parameter measurement system, so it is important to capturing 3D video of fish from its real movement. So we are using a 50 centimeter length and 30 centimeter width a glass box as our fish tank. In this fish tank, we have put one by one our fish samples and collect its length and height for our test data. As we have seen that camera is used for collecting our data, now let's go to see how we fix this camera setup. We have used different sizes and shapes of object to find the minimum and maximum region it can detect perfectly. This is a 2 by 2 object that we have used. When red circles show the camera, it can detect the object. Now camera can detect. Now camera cannot detect the object. See, if a 2 by 2 object is moved very far from our camera cannot detect its distance. Now let's move to another object. This is a 5 by 5 object. Let's see how camera will find its distance. Now camera can detect. Whereas our 5 by 5 object can go far than 2 by 2 object, but camera can clearly measure its distance. Now let's see another object. This time we have used 7 by 7 object. This object cannot be identified in very far, but in it can be identified if it goes further from our 5 by 5 object. Now let's see our camera setup result. We use different sizes of object to fix our camera setup. Here we clearly see that the more bigger object we have used, the accuracy level the more increase. So for our final model, we have fixed the minimum distance about 5 cm and the maximum distance about 50 cm. After finalizing our camera setup, we are moved to build our project model. Let's see how our project model works. We have used different types of fishes as a sample of our model. Our model can detect a fish's length and height perfectly if it stays 0.2 seconds in front of our camera. Whereas our camera can detect it if it doesn't in front of our camera, but then detection cannot be perfectly accurate. These fish show head only, that's why our detection model cannot detect this time. Now as you see, this fish weighs 0.2 seconds and our model can detect this time fish correctly and calculate its length and height. For this fish, we have got average value of length 10 to 11 centimeter and height 1.1 to 1.9 centimeter. For this fish, we have got average value of length 10 to 11 centimeter and height 1.1 to 1.9 centimeter. This is our another fish sample. Model detect this fish length is about 16 to 20 centimeter and height is about 2.6 to 3.3 centimeter. And manually tested, we found this fish length is 19 centimeter and height is about 3 centimeter. This is our another fish sample. For this fish, we have found length about 6 to 8 centimeter and height is about 0.85 to 1.67 centimeters. And by manual testing, we found its actual length is 9 centimeter and actual height of this fish is 2 centimeter. This is our another fish sample. For fourth fish sample, our model is provide 5 to 9 centimeter length and 2 to 4 centimeter height. And for fourth fish, we have found by manual testing that it is 10 centimeter length and its height is about 3.3 centimeter. Now let's see our model result. We have used total 30 fish as a sample of our project. All these fishes are under Actinopterygii class. We have used 6 different species under this class. Each species may have 9 samples, each are 5, each are 4 and each are 3. As we can see that each of species provides very good length accuracy as well as height accuracy. Length accuracy we found 88% to 92% and height accuracy we have found 72% to 80%. So we can say that the final model accuracy in length estimation is about 89.96% and height measurement accuracy is about 79.23%. Now let's proceed to the importance of our project. Our model can easily track the growth of fishes automatically without disturbing its real movement. It helps to understand the balanced amount of food for fishes as fish needs its food as per its size. Overeating or shortage amount of food causing a huge number of deaths for fishes. It make a big loss to the farmer. Also, our model can help them to take selling decision. If fish is very big or very small, customers are not willing to purchase that fish. As we have built an automated system, it can easily monitor all fishes at a time. So farmer can relax and use less manpower in their tank. Now let's see what we will do in future with our project module. We will use image processing in our model to detect a specific fish from a fish tank. We will set our model then underwater by attaching underwater camera instead of normal camera. Later on, we will plant it in a huge aquarium for testing. If we will find our expected result, we will plant in a hatchery of aquaculture system. This is our team members Mahisharia, Shomik Ahmed Shirsho, Nuzhat Jahan and Nomin Naj Manisha who work together to build this project. And this entire project is supervised by Mr. Rakibul Haq sir and Dr. Arif Reza Anwari sir. Without their guidance and support, it is not possible for us to build this wonderful model. Thank you for watching our project demonstration video. Assalamu alaikum.